types of numbers today. This includes multiples, factors, lowest common multiple, highest common factor, prime numbers and cubic numbers. We're going to look at a few different definitions and then we're going to try a few questions, and then you'll be able to answer your homework on MathsWatch. So we'll start with multiples. Multiples are numbers that basically come in the times table of another number. So for example, the first few multiples of 3 would be 3, 6, 9, 12, 15 and so on. The first few multiples of 7 would be 7, 14, 21, 28, etc. The first few multiples of 13, 13, 26, 39 and so on. Pretty straightforward. Let me show you a simple example then. So if I said to you, what are the first the first 4 multiples of 9? 4 multiples of 9 are 9, followed by 18, followed by 27, 36, 45, and so on. Okay. So those are the first 4 multiples of 9. Now you need to try for yourself. Pause the video now and have a go at these. Okay, so there those are. Now you're going to have a go at these questions. List the first 6 multiples of all of those numbers. Please pause the video and try that now. List those. Now you need to try these questions yourself, so have a go at these now. Simple true or false questions now for you to try. Again, pause the video and have a go. So lowest, so the smallest number, that is common to both lists and it's in the multiples. So for example, here are the multiples of 3. I've got 3, 6, 9, 12, 15, 18. And then for the multiples of 4, I've got 4, 8, 12, 16, 20. Now the lowest common multiple is the first number that is in both lists. So the first number in this case in both lists is 12. So what I would write is the LCM of these two numbers is 12. Okay. Again, I'll show you another example. So find the lowest common multiple of 4 and 5. So again, I'll list the first few multiples. I've got 4, 8, 12, 16 and 20. Excuse me, that's supposed to be a comma, not a 1. And then I've got 5, 10, 15, 20, 25, etc. The lowest number in both lists is 20. Now, some of you will have said, oh yes, so it's easy, just 4 times 5 is 20. Now, yes, that works in this case, but it won't always work, okay? So consider, for example, if I asked you to find the lowest common multiple of, I don't know, of 10 and 4. So some of you would say, well, 10 times 4 is 40, so is the answer 40? Lowest common multiple 40? And the answer is no, it's not 40. That would be wrong. If you've got your 10 times table, you've got 10, 20, 30, 40, 50, 60, etc. And if you've got your 4 times table, you've got 4, 8, 12, 16, 20, 24, 28, etc. Now the first number in both lists, now I'm not denying 40 does come in that list eventually, if I just skip a few, eventually it will get to 40, but 20 is much earlier on in the list and that comes up. So don't assume you can just multiply the two numbers together. I know for this question, 4 and 5, yes, you could just multiply together, but that won't always be the case. So, your turn. What's the lowest common multiple of 5 and 6? Pause the video now, have a go. Again, lowest common multiple of 8 and 16, please. Oh, in fact, of 8, 16 and 24. So, pause the video now, have a go. Answer 48. Now you have a worded question. So this is an example of a LCM question. It is still LCM. I'll just write that here. It is still LCM, but it's worded. So question says, Danny wants to buy hot dogs and hot dog buns. He doesn't want any extra hot dogs or rolls. How many packets should he buy? Well, you've got 6 hot dogs in a packet and 4 hot dog rolls in a packet. So the lowest common multiple of these, 6, 12, 18, 24, and 4, 8, 12. So the LCM is clearly 12. So that's 2 packets of those and 3 packets of those. So my answer to the question would be, Danny needs to buy 2 packets of hot dogs and 3 packets of hot dog rolls. Alright, your turn. Have a go at this question. Mika wants to buy hot dogs and hot dog buns. She doesn't want any hot dog rolls left over. So how many should she buy? You've got 6 and you've got 5. Have a go. Pause the video now. Again, another question for you to try. Please pause the video now and try it. Okay, so we're moving on to factors now. Factors are numbers which go into a number, if that makes some sense. So, for example, they come in pairs and they multiply together to make a number. So, for example, the factors of 12, well, remember the first factor is always going to be 1 and that number, so 1 and 12. After that, you've got 2 and 6, and 3 and 4. Those are all the factors, all the factors of 12. There are no other factors of 12. Okay. You have a go now for these 3. Okay, pause the video, try it. There are the answers. All I'd add here is for the last one, you don't have to write down 4 twice. So in my list of factors, you'll notice I only wrote 4 once. Okay, so for highest common factor, again, as it was for LCM, you're looking for the highest number that's common to both lists, and obviously it's a factor. So 8 and 12, I'll write all the factors of 8 first, over here. So I've got 1, 2, 4, 8. I'll write all the factors of 12 over here. So I've got 1, 2, 3, 4, 6, and 12. And I'm looking for the highest number in both lists, which in this case is 4. So the HCF is 4 for this question. Okay. You have a go now and work out the HCF of 9 and 15 and HCF of 12 and 18. Please pause the video now and have a go. So this is one for us to talk about really. A carpenter has 2 pieces of wood. One is 21 centimeters long, the other is 35 centimeters long. He wants to use both pieces to make as many equal lengths of wood and not waste anything. So what you've got to ask yourself is it a lowest common multiple or is it a highest common factor question? Now the key part here is he wants to make as many as he can, and he doesn't want to waste anything. So he's talking about cutting these up. So we're cutting up existing wood, existing lengths. So that is a HCF question. Okay, so that's the first thing which some kids sometimes struggle with, is identifying what type of question it is. So this one is a HCF question. So what is the HCF of 21 and 35 is basically what I'm asking you. So in this case, I know that 7 comes in that times table and in that times table, so the answer is 7. Okay, so he should make 7 centimeter long pieces of wood. If he does that, he'll get 3 out of the shorter one and he'll get 5 out of that. So he'll get 8 lengths altogether, but they'll all be the same length, which is what the question asks for. Okay, you guys have a go at this question yourself. In an outdoor club, there are 30 boys and 24 girls. The groups need to be made with boys and girls split equally between the groups. How many groups maximum can we make? Pause the video, have a go. Okay, moving on to prime, squares and cubic numbers. Now, for this, it's really as straightforward as understanding each of them separately. So, prime numbers are numbers divisible by 1 and itself. So, what this means is they only have two factors, 1 and itself. So, for example, the number 3. The only way to make 3 is 1 times 3. The number 5. The only way to make 5 is 1 times 5. The number 7. The only way to make 7 is 1 times 7. The number 9. The only way to make 9 is 1 times 9. Oh, wait! Hopefully you spotted the deliberate error there. There is another way to make 9. So 9 is not a prime number because I could do 3 times 3. And that makes 9. Okay? Just while we're talking about prime numbers, we're going to talk about the number 2. 2 is a special prime number. It is the only even prime number. Only even prime number. And the reason for that key stage 3, the reason for that is every other even number will divide by 2. So if you think about it, the only way to make 2 is 1 times 2. But any other even number, so I could choose 4 or 8 or 12, all of those definitely divide by 2. Because in order to be an even, how do you define an even number? Well, an even number divides by 2. So 2 times 2 for that one, 2 times 4 for that one, and 2 times 6 for that one. So they all come in the 2 times table. So 2 is the only even prime number. So square numbers then. Square numbers pretty straightforward again. There is a display in each of the classrooms about square numbers. So for example, 1 squared is 1, so that's a square number. 2 squared is 4, so that's a square number. 3 squared is 9, so that's a square number. 4 squared is 16, so that's a square number, and so on. Alright, so square numbers are the answer to something times itself. What do you think cubic numbers are? Pretty much the same thing, except the answer to 1 cubed. So 1 cubed, again, is 1. 2 cubed, 2 times 2 times 2 is 8. 3 cubed, 3 times 3 times 3 is 27. 4 cubed, 4 times 4 times 4 is 64. And these are called cubic numbers. All these ones here are called cubic numbers. So remember, the square numbers are the answers to a something times itself question, and cubic numbers are the answers to something times itself times itself. So this is just an extension of what we've talked about regarding square numbers. You can talk about them as something to the power of 2, something to the power of 3. It's called index notation. Can you please work out the answers to all of these questions? Try that now. I'll just remind you that that means 4 times by itself, which would be 16. So I've done the first one for you. You can pause the video now and have a go at the rest. An activity for you to try. This means square root, which is the opposite of squaring something. So the answer really to this one is 3, because 3 times itself makes 9. Pause the video now, have a go. There are the answers.